Welcome, everyone. I want you to imagine the ultimate battleground for a second. Picture it. It's the Cambridge IGCSE Physics paper, specifically syllabus code 0625. The clock on the wall is ticking relentlessly. The tension in the exam hall is absolutely palpable. You can literally hear a pin drop, and you are staring down a heavy-hitting, multi-mark question on stellar evolution. Now consider two very different types of students facing this exact high-stakes moment. First, we have Alex. Now, Alex is the kind of student who overloads every single answer with just raw, unfiltered physics facts. When a question asks about a star, Alex practically writes out the entire history of the universe, but gives absolutely zero analysis. It's just a data dump. Then we have Sam. Sam is constantly rushing, sweating, racing against the timer, and completely missing the command word requirements on the paper. They both just handed in their exams, and guess what? Both of their papers are coming back bleeding in red pen marks. Well, we are here today to completely flip that script. We are going to transform those red marks into green check marks. Because listen, mastering this paper isn't just about what you know, it's about ancient warrior wisdom meeting modern exam strategy. It is about learning to slice through these complex questions with absolute, undeniable precision, like a samurai wielding a katana. Let's get into it.
So I really have to pose this critical question to you right off the bat. What truly separates a B from an A star in IGCSE Physics? Seriously, think about it. It's not merely a matter of raw intelligence, and it certainly isn't just about memorizing the textbook cover to cover. I mean, Alex memorized the textbook, right? And Alex is sitting on a solid B. Sam studied for hours, grinding through notes, but Sam is barely scraping by. The fundamental difference, the ultimate secret weapon here, is knowing exactly what the examiners are looking for and then delivering it in the precise format they demand. It's all about the assessment objectives. You have to demonstrate not just knowledge, but true application and critical analysis. If you cannot structure your answer to align with the examiner's hidden rubric, frankly, all the physics knowledge in the world won't save you.
So, here is our battle plan for today's explainer. First, the examiner's warning. Second, low-mass star evolution. Third, high-mass star evolution. Fourth, the method mark strategy. And finally, deconstruct, solve, and evaluate. We're moving fast, so stay with me. Okay, let's dive into section 1, the examiner's warning, and how we can avoid the traps that everyone else falls into. We are going straight to the source here. We're decoding the principal examiner reports, and this applies whether you're taking syllabus codes 0625, 0651, 0652, 5044, or even stepping up to 9702. The examiners are practically begging students to stop making the exact same easily avoidable errors year after year. Let's look at the top 3 mistakes pulled directly from those reports. Number 1, confusing cause and effect in star evolution. Students constantly mix up what triggers the expansion or what actually causes a supernova. Number 2, forgetting to check format and presentation. This is exactly where Sam fails. Sam ignores the specific command words like describe or explain and just scribbles down a messy, bulleted list. Number 3, answers are not specific to the context given. And yep, this is Alex's downfall. Alex writes a beautiful, poetic essay about gravity, but the question was specifically about a red giant forming a planetary nebula. 0 marks. To beat these mistakes, you need to structure every physics answer using the Peel framework. Point, evidence, explanation, link. We're going to break that down. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on right along to section 2, low-mass star evolution. Let's look at the standard life cycle.
Let's look at the absolute linear logic of a standard star, kind of like our sun. If you don't know this perfectly, you literally cannot apply the Peel framework. So let's break it down so you can never, ever confuse the cause and the effect. Step 1, the star eventually runs out of hydrogen fuel. That right there is the cause. The effect, step 2, without that outward pressure, the core collapses and the outer layers expand, turning it into a red giant. You must state this clearly. From there, step 3, the red giant sheds its outer layers to form a planetary nebula. And finally, step 4, it leaves behind a dense, hot white dwarf right at the center. Now, if Alex were answering this in an exam, he would write a massive paragraph about nuclear fusion without ever actually mentioning the white dwarf. And if Sam answered, he would rush it and just write, hydrogen stops, then white dwarf. You need to hit every single milestone on this timeline to extract those full marks. Let's use the Peel framework. Point. The star runs out of hydrogen. Evidence. It can no longer sustain outward radiation pressure. Explanation. This causes the core to collapse and the outer layers to massively expand into a red giant. Link. Ultimately, this forms a planetary nebula, leaving a white dwarf at the center. Boom. That is how you use peel to guarantee maximum marks.
All right, Section 3, high mass star evolution. Let's look at the massive stars. Let's see how this builds upon what we just learned, shifting our focus to the parallel, much more explosive pathway of massive stars. Now, the starting trigger here is completely identical. Hydrogen fuel runs out. But because we are dealing with a significantly more massive star, it expands into a red supergiant, not just a standard red giant. Then comes the spectacular difference, the real showstopper. The red supergiant explodes as a supernova. This massive explosion forms a gigantic nebula containing hydrogen and all those newly forged heavier elements. And what is left behind in the wake of that destruction? The core collapses so violently that it leaves either an incredibly dense neutron star or a black hole. And let me tell you a secret, the examiner absolutely loves to test this final detail. They want to know that the resulting nebula from the supernova may eventually clump together to form entirely new stars with orbiting planets. Do you see how rich and interconnected this timeline is? You cannot afford to skip steps or mix up a red giant with a red supergiant. Precision here is your blade. You have to be sharp. And this brilliantly illustrates the kind of comparative analysis that Cambridge practically demands for those elite A star grades. On one side of the ring, we have the white dwarf, the remnant of a standard star. On the other side, the neutron star or black hole, the remnant of a massive star. Cambridge wants you to identify the similarities and differences using comparative connectives. Both of these are end stages of stellar evolution, right? They both happen after the hydrogen fuel runs out. However, and this is a big however, whereas a white dwarf is surrounded by a planetary nebula, a neutron star is the direct result of a violent supernova explosion. Did you notice how I used the connective whereas? That right there is how you construct an elite top-tier answer. It shows the examiner you aren't just listing facts, you are actively analyzing the physics. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to it. To ensure you never fall victim to confusing this timeline, you need a bulletproof system. You need a memory hack. Create a mnemonic using the first letters of the key terms. For standard stars, remember, hydrogen runs out, red giant, planetary nebula, white dwarf. That's HRPW. For massive stars, hydrogen runs out, red supergiant, supernova, neutron star, or black hole. HRSN. I want you to lock this into your brain right now. When you walk into that exam hall and sit down, jot these letters down at the top of the page immediately. It literally acts as an architectural blueprint for your answers, ensuring you follow the exact chronological flow that the grading scheme requires. Section 4, the method mark strategy. This is where we learn how to show you're working like a pro. Okay, we've mastered the theoretical physics of the cosmos. The stars are sorted. Now we shift to the ultimate exam methodology required to extract every single possible mark from the paper. I'm talking about leaving absolutely nothing on the table. There is a direct examiner alert you must memorize, and it goes like this. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Think of this as your absolute best insurance policy. Remember Sam? Sam rushes, does the math in his head, and just writes down a final answer. If Sam miscalculates by even 1 decimal point, Sam gets a big, fat 0 marks. But if you show the method, if you write down the actual physics formula, if you carefully plug in the values and then make a silly calculation error at the very end, you still secure the vast majority of the points. The method proves your conceptual understanding to the examiner. It is the ultimate secret weapon for surviving a tough paper.
So how do we guarantee we get those method marks every single time? We use a strict procedural framework. Let's do a mental workshop right now, a little speed writing challenge. Imagine a flawed physics paragraph on an exam that just says, the star runs out of fuel and becomes a black hole. Okay, what's the flaw there? Think about it. It skipped like 3 massive stages. Now let's use our 5-step framework to fix it. Step 1, identify key elements. We are dealing with a massive star here. Step 2, apply relevant principles. This sequence has to go from red supergiant to supernova before anything else. Step 3, execute analysis with clear working. Write out the steps sequentially, don't skip ahead. Step 4, verify results. Did you mention the heavier elements forming? Step 5, present in the appropriate format. Use that peel paragraph structure we talked about. Point, evidence, explanation, link. If you follow this exact 5-step standardized sequence to process your physics questions, you prove your conceptual depth to the examiner every single time. It completely removes the guesswork.
Almost there. Section 5. Deconstruct, solve, evaluate. Pushing beyond breadth to true analytical depth. This brings us to our final, overarching strategic framework. We are moving way beyond just identifying a concept and solving an equation. We are aiming to hit the distinct cognitive domains that Cambridge specifically requires for their top-tier A-star candidates: knowledge, application, and analysis. Evaluative thinking is the absolute pinnacle of the Cambridge syllabus. It means questioning assumptions, considering different perspectives, and justifying your decisions with hard evidence. When a heavy 7-mark question asks you to compare the life cycle of a sun-like star with a massive star, you don't just list facts like Alex does. You evaluate. You justify why a supernova only happens in a massive star based on gravitational forces and core mass. You explain the physics behind it. You push beyond superficial breadth, and you dive deep into analytical depth. This right here is the complete physics answering system. Decode the command word, apply the Peel framework, show your method clearly, and manage your time systematically. So, I leave you with this final provocative thought. Will you just be like Alex, stubbornly memorizing facts without any real structure? Will you be like Sam, constantly rushing, panicking, and throwing away easy marks? Or will you execute the examiner's blueprint on your very next past paper question? The choice is entirely yours, but you have the tools now. You have the knowledge of star evolution, from hydrogen depletion to white dwarfs and black holes, and you have the warrior's strategy to articulate it perfectly on the page. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.